Hello everyone, welcome back. In this lecture, we are going to solve few previous year GATE questions on IEEE 754 standard. Before that, just quickly recall, there are two formats in IEEE 754 standard. One is single precision, another is double precision. So in single precision format, sign bit is represented by 1 bit, 8 bit are reserved for biased exponent, and 23 bits are reserved for normalized mentation, and the value of bias is 127. In double precision, 1 bit is reserved for as sign bit, then next 11 bits are reserved to store the biased exponent, and then the remaining 52 bits are reserved for normalized mentation, and the value of bias is 1023. So with this detail, let's take one question from GATE 2014. So let's say this is the question. In this question, try to read it carefully. So in this question, the value of floating point variable they have given using the single precision 32-bit format. Single precision 32-bit format, IEEE 754 standard. So they are also mentioning 1 bit for sign bit, 8 bits for biased exponent, and 23 bits for mentation or normalized mentation. A float type variable is assigned. The decimal value of that float type variable is minus 14.25. So the value is given minus 14 or 14.25 base 10. This number is negative. That means sign bit will be 1. So sign bit value, sign bit will be 1, that's for sure. Now let's represent 14 and this 0.25 in binary first. So when we represent these things in binary, 14 will be represented. So let's say how many bits will be required to represent 14? In 4 bits we can represent maximum value 15. So 1 bit it is set, then this is, and this is 0. So 14 will be represented like this in binary. How this first place is representing place value as 1, this is 2, this is 4, and this is 8. So when we are setting 1, 1, 1, that means 8 plus 4 plus 2, and this place is 0, so that means 8 plus 4, it is 12, 12 plus 2, 14. So that means this portion will represent like 1, 1, 1, 0. Right. Now after the point or this decimal point, we have this 0.25. When we are having 0.25, we start multiplying this with 2, and when we multiply very first time we will get 0.5. That means the 0 will be considered here. Now when we again take this 0.5 and we multiply with 2, we will get 1.0. So this one will be considered here. So that means the binary representation of 14.25 is 1110.01. Now when we write it in normalized way, we will write it like 1.11001, and because it is in binary, we will write 2 to the power 123, 3 bit here, that means it is positive 3. Okay, so this will be represented like this. That means this exponent is having positive value. When we normalize it, we need to add 127. So the bias value in single precision is 127. So when we represent exponent need to be represented as 3 plus 127, that is 130. So when we represent 130 in binary, again you can take 128 plus 2. So 128, the 8th bit is 1, then 0, 0, 0. So let's say there are 8 bits. So these 4 bits, 5, 6, 7, 0. So this is 128th place and this is second place. So 128 plus 2 will give you 130, right? So this is your exponent. Let me wipe it out. So we will get the value of exponent like this. I'm writing it here, 1 0 0 0 0 0 1 0. This is the exponent. The rest of the things I'm cleaning. Right. Now we need to find out the normalized mantissa. So what is mantissa? Mantissa is this remaining portion. This mantissa will give you 1 1 0 0 1 and the remaining bits. So these are only 5 bits. Remaining 18 bits will be 0 1 2. So this is your normalized mantissa. Now altogether if you present this, so sign bit is 1 because the number is negative minus 14.25, so sign bit is 1. Then the exponent is, so let me write in different color, 1 0 0 0 0 0 1 0, and then the remaining mantissa parts of 1 1 0 0 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. The rest of the thing you can consider, right? So this is 1 2 3 4 5 6. I'm making the group of 4 4, right? So this is 4 because I need to convert this bit pattern into hexadecimal. So we are forming the group of 4 like this. We are forming the group of 4 like this. We are forming the group of 4 like this. Remaining will be 0 only. 1 2 3 4 5 6 7, and then remaining 8 groups of 4 4. So this 1 1 0 0, that means 8 plus 4 12, and an hexadecimal 12 means C. So this is representing C. That means B and C are wrong, right? The next place is 0 0 0 1, so that means it is 1, C1. Okay, so after C we are getting 1, after C we are getting 1, so this place is giving you 1. Now the next is 0 1 1 0, that is 2 plus 4 6, so 6 is 6 only. This is giving you 6 and this is giving you 4. C164 C164, and then remaining 0. So this is 0, this is 0, this is 0, this is 0. H is representing like hexadecimal, so that means answer A is correct. I hope you are getting it. So I am ending this lecture. Thank you everyone for connecting.